exceptions, try-catch, exception handling, throw, rethrow, ContinueOnError or Retry Scope. We hear these definitions in UiPath over and over. But what do these definitions mean? How to use them and why we use them? If you want to learn more about the topic, please watch this video to the end. I will explain it in very easy way. So if you don't have any idea about the topic and want to learn it in easy way, the video is perfect for you. Let's go. First, let me explain to you, what does an exception mean? Let's see the definition of an exception. It's an error that occurs during the runtime of a code or a program. The emphasis here is on error and during runtime. It means that something in the code is going wrong, and it happens only during the execution of the code. So make sure you don't confuse between exception and error. Let's see the following example to better understand the difference between error and exception. I will create a string variable. Let's set a value for this variable. I will write the value without semicolon. As you see, we have here an error and it happens before executing the code. Let's see the error. It's a compiler error. This means that errors are events that a particular program can't normally deal with. If we have an error in the code, we are not able to run the code yet. Let's try to run the code. As you see, we get error and are not able to run the code. We have to resolve the errors, so that we can run the code. In this case, we have to write semicolon for the value, because it's a string variable. Now we don't have the error anymore. I can run the code without any issues. Let's now see, what does exception mean and how it occurs? As mentioned, exceptions are errors, which occurs during the runtime. Let's create an integer variable. I will it also an assign activity. I want to convert a text to integer. I will do this as follows. We use the function cint and then I write the text in brackets, which should be converted into integer. As you see, we have here only text, therefore it cannot be converted into integer. But we don't have any errors currently. Everything seems to be okay. Let's run the code to see what happens here. Oops, there is an exception. As you see, we have here some details about the occurred exception. We have three information. The source, in which activity the exception occurred. The message, why the exception has occurred. And the exception type of the occurred exception. Let's talk about these three information. Let's start with exception type. As you know, we can define variables in code of different types, such as string, integer, data table, etc. We can also define a variable of type exception. Exception data type has also different properties, such as message, source or exception type. These properties help us to get more details about the occurred exception, so that we can better handle the exception. There are many different exception types. For example, business rule exception, system exception, application exception, invalid cast exception, etc. The type depends on the exception, why this exception occurred. In our example, we tried to convert a text string into integer. We couldn't convert it, therefore we got invalid cast exception. Let's see other example. I will add read range activity. Let's say I want to read this Excel file. I will copy the path. Let's add the path to the activity. I will first open the Excel file manually. Now I will run the code to show you that we will get an exception, because the file is opened. As you see, we have this exception. It's another exception type. As you see, we have different types of exceptions. Let's move to the next part of an exception, message. In message we get some details: what is the problem? Or why is the exception occurred? That's all about message. And the last one is source. In source we get the place where the exception is occurred. It means, in which activity is the exception occurred. In this case we got the exception in read range activity. It's recommended to rename the activities in a workflow, so that you can better know where an exception occurred. What do I mean here? Let's say, we have these two assign activities. The first one is okay and causes no exceptions. The second one causes exception. I will run the code now. As you see, we have in source the information that the exception is occurred in assign. But I don't know which assign activity is meant here. Therefore it's better to rename the activity. I could know in which activity the exception is occurred, using the message and the exception type, but it's more effort, therefore try to rename each activity you add into your workflow. That's all about exceptions and errors. I hope you could now better differentiate between error and exception. Let's now move to the next point. Exception handling. What does this definition mean? Exception handling is the process of responding to the occurrence of exceptions during the execution of a program. This means that we integrate exception handlers into the code, so that not every deviation from the instructions immediately leads to an error code. So the exception handler is the code which takes care of handling the exceptions. We use exception handling to avoid the immediately aborting of a code. We have different mechanisms to handle an exception. The most popular mechanism is the trycatch statement. I will talk about this statement in a moment, then I will introduce you to the other mechanisms, how they work, and when we should use them. Let's start with trycatch statement. It consists of three parts: try, catch, and finally. Try is the place where we enter the code, which is prone to error. This means, if we have a part of code which could cause exceptions, we can write it in the try part. Try means in this case, that we try to execute something, but we are not sure if the code will run without any errors, or if any error may occur. The next part is catch. Here we set the exception handler. It means, we set a code here, which should be executed in case of an exception. But only for exceptions, which occurred in try. It means, that we handle only the exceptions, which occur in try part. And the last part is finally. Here we can add a code, which should run regardless the result of the previous parts. It means, if try is completed without any exceptions, the finally sector will be executed. But also in case of an exception, which is handled in catch sector, the finally sector will be executed. In summary, finally part will be always executed after try and catch. Let's summarize the meaning of these three parts. Try contains the risky code. Catch is the exception handler. And finally is a code to run regardless the result of try and catch. Let me show you some scenarios, which we could have using this statement. Assume we have a code in each part, try, catch and finally. The first scenario is, if try code causes no errors. Here the code in try is executed. Then we move on to the finally part, without executing the catch part. It means, in this scenario only try and finally are executed. The next scenario is, if we have an exception in try part. In this case, the try part is executed. Then we get an exception. In this case we move on to catch part. The catch part is executed. At the end the finally part will be executed. The third scenario is, if try part has exception, and also catch part has exception. In this case, the try part will be executed. Then we get an exception and move on to catch part. In catch part we get a new exception from the code. In this case, the code will be broken down and the execution is stopped. Why this happens? Because as mentioned, the catch part will catch only the exceptions from the try part. Therefore we have to make sure that the code in catch part causes no exceptions. So if we are not sure if the code in catch part is stable and causes no errors, we have to set a new try-catch statement for the code in catch part. It means that we can use more than one try-catch statement in the code. And we also can use more than one try-catch statement within try-catch statement. The same is also for the code in finally. I mean, if you are not sure that the code in finally part will be executed without any errors, you have to use a try-catch statement. Let's switch to UiPath to show you how to use try-catch statement. Assume we only have this assign activity. We have a variable of type integer. I use the cint function to convert a text into integer. As you see, we have here a number which can be converted into integer, without any errors. I will add a try-catch activity. I will set the assign within the try part. Then I have to add a catch. Here we have first to select an exception type. It means, here we have to select a type for the exception, which could occur in the try part. If you don't know which exception type could occur here, you can use the general system exception type. This type catches each kind of exception. I will talk about exception types in details later in the video. I will add a log message activity in the catch part, which should be executed in case of exception. And in the finally part I will add another log message activity, to show you what happens in case of completed or exception. As you see, we have here a number, therefore it should work fine and we shouldn't get any exception. Let's run the code to check it. As you see, we have here only the log message from finally part. It means, the try and finally parts are executed. The catch part was not executed, because we didn't have any exception. Let's now change this number into a text. In this case we should get an exception, because we cannot convert a text into integer. It means, this log message should be executed. And the log message in finally part should be also executed. Let's run the code to check. As you see, we have first the log message from catch part. And then we have the other message from finally part. It means, as already mentioned, finally part will be always executed regardless result of try and catch. Let me show you something else, how to add a try-catch activity in other ways. I will delete this try-catch activity. I will select the assign activity and right-click with mouse. We can select this option to add try-catch activity for this activity. Or we can also use the shortcut, Ctrl+T, to add try-catch activity. I will add try-catch activity again. As you see, the activity will be directly placed in try part. I will select an exception type again. And also a log message activity. This time I will use the log message to get information about the occurred exception. For this I write exception. Exception is the variable, which is automatically defined in this field. You can rename it as you like. And for this variable there are different properties, which I mentioned at the beginning. I will use message property to get the exception message. I will add also a log message activity in finally part. Let's run the code to see the new output. As you see, we have here the exception message, which tells us why the exception has occurred. And below we have again the message from finally part. Let's see another example to understand the try-catch statement better. Assume we have this process, where I read an Excel file. Then I want to write the content of a column into the console. I have first read range activity, where I have the Excel file path and the sheet name. I stored the data into variable Excel_DT. And then I have this loop for each row, where I print the content of column city name into console. Here is also my Excel file. It consists of two columns, ID and city name. I will leave the Excel file open. In this case I will get an exception, because I cannot read the Excel file while it's open. Let's run the code to see what happens. As you see, I got this exception of type system.io.io exception. What does it exactly mean? I will let you know after explaining this example. You can also see in the message that we cannot read the Excel file because it is being used by another process. Let's add a try-catch activity. I will move the first activity into try part, and the loop into finally part. I will add here an exception. I will use the general system exception, which can handle each type of exceptions. I will also add a log message activity. I will write some text here. Let's run the code to see what happens. As you see, the Excel file is opened, therefore we got an exception. In this case we moved on to the catch part. Here you can see the text from the log message. It means that everything is okay until this step. But now the finally part should be executed. Here we got another exception, because we didn't read the Excel file. Therefore the data table doesn't contain any column and we got an exception. It's not a matter now, what happens in finally part. Let's focus on catch part. As you know, we cannot read the Excel file because it's opened. Therefore we have to close the Excel application. Then we can again read the Excel file. So I will add kill process activity. Then I will copy the same activity from try and put it in catch. In this case, if we have an exception in try, we will move on to catch part. Here the Excel application will be closed and then we can read the file. Let's summarize what should happen here. First, in try part we try to read the Excel file. In case of exception, we move on to catch. First the log message is executed. After that the Excel application is closed and the file is read. At the end, using the loop we get the city names. Let's run the code to check if this is correct. As you see, we have first the message from log message. It means that we got an exception. In this case, we moved on to kill Excel. And then we read the Excel file again in catch. After that we see the city names. In the finally part we wrote the city names into the console. As you see, I used the general system exception in the catch part. But this is very general and I could have another exceptions. I mean, the exception must not be always the same, that the Excel file is opened. Maybe the file doesn't exist, or the sheet doesn't exist. In this case I will get another exception. And for this exception it makes no sense to add kill Excel and read the file again. Therefore we have to differentiate between the exceptions, which may occur. Therefore we have to use different catches using different exception types, depending on the occurred exception. I mean, we have to use the system.io.io exception to handle the exception, which may occur if the Excel file is opened. In this way I know what I have to do in case of occurrence of this exception. I mean, if this exception occurs, I need to close Excel and then try to read Excel again. But in case of that the Excel file or the sheet doesn't exist, I have to handle the exception in another way. For example, I can send an email to the process owner to tell him that the Excel file doesn't exist. In this way we can better manage the exceptions and make our processes more stable. Let's add a new catch using the IO exception. I will copy the sequence from the previous catch and put it here. I will change the log message content to know which catch is used in case of exception. I will also leave the first catch as it is now. It means, we have now 2 catches. This means that we could add many catches into a try-catch activity. I will first open the Excel file, so that we get the exception again. Let's run the code to see what happens. As you see, we have this message. It's from the new catch, which I added into catch part. And below we have the city names. It means that everything is done successfully. As you know, both catches could catch the occurred exception. But UiPath selected the second catch. Why? How does the catch work, in case we have more than one catch which could catch the occurred exception? Let's see how it works. Once we get an exception in try part, we move on to catch part. UiPath searches for the most matched exception from the catches. For example, we had these 2 catches in our process. We have this exception type. The first catch can catch this exception. The second catch also can catch this exception. But the second catch matches better than the first one, because the first one is general. But the second one is exact the same exception type. Therefore UiPath will use the second catch. And so it works in case we have more than one catch. It's recommended to use the different exception types, not the general one. I mean not the system.exception. In this way you can better handle each exception depending on the exception type. But which exception types do we have? You can see all exception types in UiPath. Just click on Browse for Types and you will see all exception types, which can occur in a project. As you see, there are many different exception types, which we can use to catch the different exceptions. But how to know which exception could occur, so that I can select the correct exception type? I will show you that later in this video. Let's now add a new catch for another exception, which could occur. For example, if the Excel file or the Excel sheet doesn't exist, I will get an argument exception. So I will add this exception type. Let's add a log message. I will write some text here. Then I will add the message from the exception, so that I can know what is the exception exactly. I will delete the system.exception. So in try we have read range activity. If the Excel file is being used by another process, we will get the first exception. But if the Excel file or the sheet is not available, we will get the second exception. In this case we have to handle the exception in another way, as we did in the first exception. We cannot do anything if the Excel file doesn't exist. From developer side, it's a business rule exception. Therefore, we need to convert the argument exception into a business rule exception. We can do this as follows. In catch, we can add throw activity. Throw activity is to create and throw an exception by ourselves. In this case, we need to throw a business rule exception. We can do this as follows. Just write new, and then the exception type, for example business rule exception. Then in brackets we can define which message should be thrown. Either we write a text in semicolon, or we can also use the exception message of argument exception from catch part. I will use the exception message. In this way we converted the argument exception into business rule exception. It means that we still have an exception in the code. So why we should do this? What is the benefit of doing that? I will tell you that in a moment. I will change the sheet name to sheet 2, which doesn't exist in the Excel file. In this case, I should get the argument exception. Let's first run the code to see what happens. As you see, we have first the message from the log message activity. Here is the message of the exception. And then we have again the exception message, but from the throw activity. I will click on continue, to show you what happens then. As you see, we got this exception. Source is throw activity. Message is what we defined in the throw activity. And then you can see, that the exception type is not more argument exception, but a business rule exception. This exception can you catch in the process again using trycatch. Then you can, for example, set the transaction item as business rule exception. Let me show you now how to know which exception type should you select in the trycatch activity. You always need to add the activity which you want to execute and could have exceptions. Then run the code. You will get an exception. Here you can read the exception type, which you have to use in trycatch. For example, if we have this activity to convert a text into integer. We will get this exception. In this case, if we want to use the exact exception type, we can use this one. But if we want to catch each exception, which may occur, we can always use the general system.exception, which catches each type of system exceptions. Let's now talk more about throw activity. Throw activity, as mentioned, is to create and throw an exception. We mostly use this activity to create a business rule exception. But it could be also used for other exception types. Why we use this activity? Let's see the following scenario. Assume we want to check if a file exists in a specific folder. If the file exists, it's okay and we can go ahead to the next steps. But if the file doesn't exist, it's not correct from business side and the process owner needs to know that the file doesn't exist. In this case we can use throw activity to create an exception, which tells us that the file doesn't exist. Because if we use the activity file exists, we don't get any exceptions, only true or false. So no exception. Therefore we use throw activity to create this exception. How to create the exception in throw activity. I showed you already, but let's see it again. We write always new at the beginning. Then we write the exception type. For example, business rule exception, application exception, argument exception, etc. So we can add any exception type here. And then in brackets we can write a text, such this text here. Or we can also use variables here. Where can we use throw activity? Everywhere in the code you can use this activity. It must not be in a try-catch activity. That's all about throw activity. Let's now move on to the next activity, rethrow. As the name suggests, rethrow activity is to rethrow an exception, which we caught before. This means that we use this activity only in catch part within try-catch activity. The result of this activity is an exception. But we already caught this exception before. Why we should use this activity? In some scenarios we have exceptions in the process, which we don't want to handle but we want to get in our process. And before getting the exception we may need to do some steps, and then to throw an exception. Rethrow activity is very helpful here. What does this exactly mean? Let's see the following example. Assume we have the same example as before. We want to read an Excel file, which doesn't exist. But this file is important for the process. It means, without the file, I cannot execute my process. This means that we have to stop the process at this point, if the file doesn't exist. I have here argument exception. Once we get the exception, we move to this part. Here we can, for example, use send mail activity to inform the process owner that the Excel file doesn't exist and the process will be stopped. After that we can use rethrow activity to throw the exception again. In this way we inform the process owner, and we stop the execution of the process, because of the exception. As you see, we don't need to add anything for rethrow activity. We only have to add it into the process. And we can only use this activity within catch part, because only here we have an exception, which we can rethrow. Let's try to add this activity somewhere else. As you see, we have a compiler error, that the activity can be only used in catch. That's all about rethrow activity. Let's now move to the next point, ContinueOnError. As the name suggests, it's an option to continue executing the process, even if an exception occurs in the activity. For example, we have an activity, which could produce an exception. If we set ContinueOnError equal true, it means that we want to ignore the exception and continue. So this option is to ignore the occurred exception. We have this option for some activities in UiPath, not for each activity. We mostly use this option for the activity, kill process. If we use kill process activity to close an application, which doesn't running, we will get an exception. To ignore this exception we set ContinueOnError equal to true. In this way we ignored the exception, and moved on to the next step in the process. As mentioned, this option is not available for each activity. If you leave the option empty, it is the same as when you set it equal to false. So you can leave it empty or set it false. In this case you will get an exception, if the activity is not successfully executed. And if you set it true, you will not get any exception, if there is one. This property can be used for each activity, where the option is available. So it must not be in try-catch activity or somewhere else. I recommend to not use this property, because you cannot know if any exception in the executed activity occurred. It's better to use try-catch activity. Only for the activity kill process could be helpful. Or in general this option is to use, if the execution of the activity doesn't matter if successful or not. It means, if the activity is successfully executed, it's okay. And if the activity is not successfully executed, I don't have a problem with that and I can continue running the process. That's all about this property. Let's now move to the last point in this video, Retry Scope. Retry Scope consists of two sections, action and condition. In action we add the activities, which we want to retry. In condition we add a condition activity to break the retry loop. Important for condition section, that we can only add activities, which has a Boolean result. It means, that we can add only activities, where the output of these activities is true or false. For example, element exists, image exists, etc. We cannot add activities like assign, or open browser or such activities, where we don't have a Boolean result. The retry scope activity retries the activities in action section, as long as the condition is not met or an error is thrown. It means that we retry execution the activities, until the condition is met. We have two properties for this activity: number of retries and retry interval. In number of retries we can add the number of times that the activities in action section are to be retried. In retry interval we specify the amount of time in seconds between each retry. Let's see how this activity works, using different scenarios. At the beginning the activities in action sections will be executed. Here we could have an exception. If we don't have any exceptions, the condition will be checked. If the condition is met, the activity is done. Assume we get an exception in action section. In this case the number of retries will be checked. It means, UiPath checks if we still have retries or not. If we still have a retry, we move on to wait stage. Here the robot waits the time, which we defined in the properties. It means the retry interval. For example, if we set 5 seconds, the robot waits 5 seconds, and then the activities in action section will be executed again. If the number of retries is exceeded and we have an exception, the exception will be thrown. Number of retries is exceeded means, for example, we set 3 retries, and the activity is 3 times executed without success. The last scenario is, if we don't have an exception, but the condition is not met. In this case we have an infinite loop. It means that the robot doesn't do anything and still waiting for the condition to be met. In this case the activity will not be retried, because we should have an exception, so that the activity will be retried. In general, if we have a condition in retry scope, we should have an exception in action section, so that the activity can be retried. But if we don't have a condition, and also no exception, the activity will be executed only one time. Let's summarize the different scenarios. The first scenario: we have no exception, but the condition is met. Here the activity will be executed one time. The second scenario: we have an exception and the condition is not met, the activity will be retried. After retry all number of retries, if we still have the exception, it will be thrown. The third scenario: we have no exception, and also no condition. In this case the activity will be executed only one time. The fourth scenario: we don't have an exception in action section, and the condition is not met. In this case we have an infinite loop. These are all scenarios, which we could have in a retry scope activity. Let's now implement these scenarios in UiPath, so that you can understand these better. The first scenario was, if we have no exception and the condition is met. I have here a retry scope, where I have only a log message activity in action section. In condition I have element exists activity, which checks if the notepad is open. As you see, the activity in action doesn't cause any exceptions, and the notepad is opened. It means that the condition should be met. I have here 3 retries. And the retry interval is 5 seconds. Let's run to see the result. As you see, we have the log message only one time, and we have no errors. It means that the code is only one time executed and it's successful. Let's move to the next scenario. Here I have an assign activity, where we will get an exception, because we cannot convert a text into integer. And I don't have the notepad open, which means that the condition will not be met. Let's run the code to see the result. As you see, we have an exception, but this exception is not thrown from the first retry, but after all retries. The loop is executed 3 times, because we have this text 3 times. Let's move to the third scenario. Here I have no exception, and I didn't use any condition. Let's see what happens. As you see, we have no errors and the loop is only one time executed. And the last scenario if we have no exception and the condition is not met. I have here only this log message activity, and the notepad is not opened, which means that the condition will not be met. Let's run to see the result. As you see, UiPath still running and we have here an infinite loop, because there is no exception and the condition is not met. That's all about the Retry Scope activity. So we are now at the end of this video. Let me now summarize the most important points from this video, which you should know. Exception is an error that occurs during the runtime of a program. Trycatch activity is to handle exceptions in the process. It consists of 3 sections: try, catch, and finally. Try contains the risky code. Catch is to handle the occurred exceptions. Finally is where we set activities, which should run regardless the result of try and catch. In catch we can add different catches, depending on the occurred exception. So you can add different exception types, and for each catch you can add different activities, which should be executed once the exception occurred. Throw is to create an exception. We mostly use this activity to create a business rule exception. We can use this activity everywhere in the code. Rethrow Activity is to rethrow an occurred exception. It can be only used in the catch sections within try-catch activity. Rethrow is helpful in case we want to throw an occurred exception, but we want to do something before. ContinueOnError is a property, which could be used to ignore an occurred exception. We set this property equal to true, if the execution of the activity is not important, if successful or not. Not each activity has this property, only some activities, such as open browser or kill process. Retry Scope is an activity, which can be used to retry some activities. The Retry Scope activity is used for catching and handling an error, which is why it's similar to try-catch. The difference is that this activity simply retries the execution, instead of providing a more complex handling mechanism. I hope you enjoyed the video and could learn something new and useful. If you have any question, please don't hesitate to write us. We are here for you. Have a good day and see you in the next video.